Hey everybody, how's it going? Of course, we had another couple of snow days, so I'm worried about getting behind. So I thought I'd make a couple videos to kind of help us get caught up where we need to be for the work that we're doing here in the labs that we've been working on. So again, apologize. I was listening to an earlier recording. I've got a little bit of a cold, but I hope you can bear with me. All right. So we've been talking about statistics a little bit. We've introduced some terms. We need to build upon that a little bit more and talk about how we're going to use stats in the experiments that you're doing. And the first thing I want to talk about has to do with sampling. So let's begin. So for these examples I'm going to be talking about in this PowerPoint and in the future ones, I want to set up a very simple hypothetical experiment. Okay? So I've got two ponds, and I just want to know which fish are bigger in which pond, okay? Because I want to go fishing for bigger fish. And so that's the question. Which pond has larger fish? So our alternate hypothesis, what I think is true, is that one of the ponds has bigger fish than the other one, right? But of course, the opposite of that, the null hypothesis, is that the fish are not different between the ponds, or they have the same size fish, okay? So we've been talking about setting up these hypotheses. Let me ask you this. Which hypothesis is assumed to be true? Take a second. Choose your answer. In this example, what do we assume is true? We always assume the null is true. We always assume there's no difference between our groups. And so in this example, we assume there's no difference between the ponds. Now, we think that one of them is bigger. Why would we do this experiment unless we thought that one of them had larger fish? All right? But we assume that there is not a difference between the two. So the question is, what will make us change our mind? Okay? If we assume there's no difference, what do we have to do to change that assumption? Put another way, how can I convince you that there really is a difference between the ponds? We start off assuming that the fish are the same size in both ponds, but what can I do to convince you that one actually does have larger fish? Well, of course, what we want to do is collect evidence or collect data that suggests that the null is wrong. That's how I'm going to try to get you to change your mind. I'm going to change that. I'm assuming that there's no difference, but I'm going to try to collect data that suggests there really is a difference. So I'm going to try to disprove the null with my data, and that will allow me to support the alternate. Okay, so here are two ponds, and I assume that the fish are the same size in each pond. How can I collect the data to suggest that one actually has larger fish? So here's the question. What is the best way to determine if one pond has bigger fish? Multiple choice. A, I can ask the anglers who fish these ponds and have them tell me which one has larger fish. B, I can drain both ponds and measure every single fish in each pond. Or C, I can measure a sample of fish from each pond. So think about your answer. What is the best way to determine if one pond has bigger fish? Well, the correct answer is actually B. Now, if you look at A, if we ask the anglers which pond has the larger fish, okay, anglers are the biggest bunch of liars on the planet. So that's not a very good answer. B does not sound like a great answer, but it is actually the best way to determine if one pond has bigger fish. If we measured every single fish in both ponds, then there's no question. It would be clear which one has larger fish. So that's the best way to determine it. Let me rephrase this question though. What is the most practical way to determine if one pond has bigger fish? Well, of course, that's going to be answer C. It's not practical to measure every single fish in both ponds. Okay. First off, if we drain the ponds, that would tell us which pond used to have bigger fish. But in real life, we cannot measure every single individual in the population. We don't have the time. We don't have the money. It's not a practical way to answer these questions. So we take a sample from each pond, we take a sample from each group, and we use that to infer and try to answer the questions about our hypotheses. Now, since we are taking samples, there's a chance for a mistake, right? We might accidentally grab all the biggest fish in one of the ponds just by chance. We might make a mistake in how we collect the fish. We might make a mistake in how we collect the data. So anytime we're not measuring every single individual, there's a chance for error. But there are ways to minimize that error. Okay? There are ways to reduce mistakes when we sample. So how can we reduce mistakes when we sample? What do you think is a good way to reduce a lot of these sampling errors? Well, we've talked about it a little bit in class. Large samples always help to reduce mistakes. So we try to get as large a sample as is practically possible. And also, the sample needs to be random and unbiased. And if we fulfill these criteria, then we've got a good sample, and that's going to help us collect evidence so that we can test our null. And that's what we're going to talk about in the next series of PowerPoints. So thanks a lot, and I'll see you in a bit.